This conference will now be recorded.
Good afternoon. My name is Greg Wadley with CTC & Associates, and I'm the Clear Roads Administrator. We're here for the final webinar for the project entitled Review and Summary of Pre-Wet Methods and Procedures, which is project number 1804. The research team from Washington State University is led by Xiaoming Shi. Before I turn it over to Xiaoming, I want to let everyone know that this webinar is being recorded and it will be posted on the Clear Roads website at a later date for viewing at your convenience. We also ask that everybody stay on mute today so that there's no background noise. However, if you have any comments or questions, please enter them into the chat box and we will address them at the end of the presentation. I believe that's all for the housekeeping items, so I'm going to turn it over to Xiaoming, and Xiaoming, it's all yours.
All right, thank you very much, Greg, and thank you everybody for being here for this final webinar for the Clear Roads project 18-04. And I'm Xiaoming Shi, and also the Washington State University team included one of my students, Dr. Shen Du, and also our outreach coordinator, Cheryl Reed, and then two subcontractors, Dave Bergner from Monte Vista Associates and Dale Keep from Ice and Snow Technologies. Hopefully within 40 minutes, I'll be able to share with you some of the key findings of this project. First of all, I'd like to acknowledge the funding by Clear Roads Pool Fund, and also thanks to this project panel for the guidance throughout the project, all the review efforts on task deliverables, for instance, and also thanks to Greg Wadley for all the coordination, and would like to thank Winter Road maintenance professionals who participated in the survey and the interviews. Would like to thank equipment manufacturers and distributors who responded to our outreach effort. And finally, my thanks go to my previous colleague, Michelle Aiken, who assisted in the proposal stage. Just to refresh our memory, the objective of this project is to compile a summary of pre-wetting practices, including equipment, materials, methods, and application rates, and identify the history of successes and failures that have contributed to the current practices. So with that, you can see our approach was outlined here, 5 different tasks. Task 1, literature review. Task 2, survey questions. Task 3, interviews and case studies. Task 4, outreach to manufacturers. And task 5, final synthesis report. You probably recall for each task, we had a task deliverable which was reviewed by this panel and approved, and task 5 deliverable was submitted and still in review. So task 1, literature review, basically aimed to review publications from recent decades, looking at the most common practices, innovative technologies, and trends related to pre-wetting equipment, systems, and materials, and also application rates, application tactic, excuse me, as well as the appropriate methodology and equipment to use under various road weather scenarios. And for sake of time, I will basically combine and integrate all the findings into the final synthesis report. So I'll focus on the findings there. But here, I just briefly go over each task and what was the original objective. So for the task 1, we also wanted to identify some scientific studies of bounce and scatter, salt activation, and corrosion inhibition related to pre-wetting. Of course, if you recall, there's not much out there in the published domain in this regard. Now, task 2 was a survey. Task 2 was a survey. Sorry, what was that noise? Task 2 was a survey we developed for online participation. So I included Clear Roads states as well as some international transportation agencies. The goal is to capture practitioner insights. Sometimes those are not in the published domain. And also we wanted to collect more detailed information about pre-wetting rates, materials, and equipment, and try to bridge gaps identified in the literature review, and also collect any sort of technical and deployment data where they're available. And also we wanted to collect feedback on what worked well, what didn't work well, and limitations of pre-wetting. So we end up having 34 valid responses, and also 20. These came from 25 U.S. agencies and 2 Canadian agencies. Of course, for certain agencies, there was more than 1 response. So, sorry, the map shows where the responses came from, except the Canadian ones. And also the task 3, based on what we found out in task 2, we identified a few responses where we want to get more details. So we identified, I think in the end, 9 case studies. Basically, these would provide examples of successful and optimum practices, and also provide sufficient detail for agencies to begin adopting new or adopting existing practices. So in the proposal, it was promised 6 to 9 case studies. Again, we end up with 9. You can see the 3 highlighted in orange are not state DOTs. They are cities or county, city or county. And then the state DOTs were Idaho, Massachusetts, Montana, North Dakota, Oregon, and Vermont. So that was a good mix of different agencies. And another outreach activity was task 4. We outreach to manufacturers. So basically, this aimed to identify equipment capabilities through some interviews with manufacturers. And again, in the proposal, promised at least 4 manufacturers to be interviewed, and we end up with 6. Unfortunately, there were some other equipment manufacturers who did not really respond after multiple trials. So I think we contacted 10, and we got 6, giving us really detailed, good information. So basically, to conclude, this project collected all available and recent information regarding the pre-wetting practice through a comprehensive literature review, an online survey, interviews and case studies of 9 selected agencies, and also outreach to 6 identified equipment manufacturers and distributors. And it should be cautioned that the following conclusions I will present in the next 20-some slides, they should be treated as preliminary guidelines or recommendations, because the pre-wetting practice have been mainly based on trial and error and field experience, not necessarily systematic or scientific investigations. That, of course, calls out the need for phase 2. The good news is there are many success stories of pre-wetting, and the pre-wetted material stays on the surface longer, has less bonds and scatter, and resists traffic action. One field study showed that 80% of pre-wetted salt remained on a road surface after 100 vehicles traveling at 38 miles per hour, while when you're dealing with dry salt, only 15% left. Pre-wetting also provides faster activation of rock salt, turning it to brine and then accelerated ice melting process. Field experience suggests typical savings 25 to 30% less salt required when you use pre-wetted salt. But again, that is not a scientific study. It was more based on various agencies' field experience. Another thing is pre-wetted abrasives can reduce the amount of material applied as much as 50% compared with dry abrasives, especially at lower temperature. And also field tests show that the pre-wetted sand resulting in higher friction improvement as high as 187% than the dry sand when used at the same application rates. The case study agencies, the 9 of them basically, also reported that pre-wetting allowed them to achieve the specified level of service quicker. Again, the challenge is that few of them actually conducted systematic investigations, with certain statistical design experiments and so on. So it's really hard to have a reliable source of information until we conduct more field tests, which are well designed, I guess. Another line of findings, I guess, mostly look at what people are using for pre-wetting. Again, no surprises. Solids are mostly rock salt and abrasives. Liquids used for pre-wetting mostly salt brine, 23% sodium chloride, And then when temperature gets colder, then agencies start using 30% mag chloride or 32% calcium chloride. And over the last decade or so, we do see increased use of beet juice as enhancer. Of course, there are people using other types of agricultural waste materials, but beet juice was the main thing mentioned over and over in the survey results, as well as the case studies. So typically, for de-icing or pre-wetting salt, the blend was 70% salt brine and 30% beet juice. But when I used for anti-icing, typically it's a 90-10 blend. And many of the respondents reported using corrosion inhibitors in the liquids for anti-icing or for pre-wetting. Again, there's not really much research in terms of whether or not the corrosion inhibitor would, especially when they add it into the pre-wetting salt, pre-wetted salt would they actually contribute to corrosion reduction. The most reasonable pre-wetting rates, again, this came from the synthesis of what we can find in literature, in survey results, in case studies. Basically, overall, you can conclude that 8 to 12 gallons per ton is sufficiently effective, even though it's still a function of the particle size distribution of the solid, how fine is your sand or how fine is your salt. We also, in another study, lab study recently, concluded that 8 to 16 gallons per ton, at least in the lab, shows that we can use that to increase the speed and total ice melting capacity of solid salt and reduce the snow pavement bond. This is a very scientific study conducted under well-controlled conditions in the laboratory. So the caveat is you don't have as realistic traffic volumes as you would have in the field. From the field experience, higher rates are typically preferred. Basically, field experience says, we tend to get better operational results, especially under cold temperature. We want to go beyond 10 gallons per ton. And that's why some agencies are starting to use these, to adopt the slurry application where you go up to 30 to 50 gallons per ton. That's feasible when your truck is equipped with pumps to make salt slurry. Again, this is a matter of the truck capability. Some of the older trucks don't really have as much a flow rate to allow this higher end of application rate or pre-wetting rate. In theory, we actually only need enough liquid to wet every particle of a dry material in order to have effective pre-wetting. But again, yeah, we need more research on this. So one thing people mentioned over and over is we need a greater pre-wetting rate for abrasives. Instead of 8 to 12, probably go for a little bit higher end. And also, when we look at how the pre-wetted salt is applied on the road versus the pre-wetted abrasives applied, you can see the application rates also differ. Typically, pre-wetted salt, you're looking at 100 to 300 pounds per lane mile. Of course, in some cases, you go up to 500 pounds per lane mile. But for pre-wetted abrasive, typically you go up to 800 pounds per lane mile. Again, you could go higher, but depending on the specific situation. So there are two things to this equation. One is the pre-wetting rate, which is the liquid to solid ratio. And the other is really the application rate of the pre-wetted material, the solids. And in practice, the rate might be also limited by tank capacity, trucks capability, and pump capacity. But we should mention that the equipment are advancing so much that these eventually will become a non-issue. And also, the rates would be ideally customized as a function of road pavement temperature, traffic volume, precipitation rate, and type, cycle time, and other operational conditions. Again, this is an area we don't have much research. Now, in terms of most reasonable procedure and equipment, all the survey respondents, and 34 of them, I guess, reported the use of onboard system to apply liquids to solids. This doesn't mean they don't do other ways, like purchase pre-wetted salt or pre-wetting at the stockpile, but looks like the trend is going towards onboard system. And the truck-mounted brine spraying equipment is typically, as you know, a liquid tank, a pump system, the spray bar, and the controller. And depending on the manufacturer or the legacy system, some manufacturers sell the entire system. Sell the pre-wetting system to be added to the in-use spreader. Some sell spreaders integrated with pre-wetting capabilities. So it really depends on how your agency. What's the legacy system your agency have? Now, the most effective way seems to be deliver the pre-wet salt, across conveyor while the truck travels at 25 miles per hour. That's a very slow speed. So on interstate, you could go up to 35 miles per hour. Now, also most civil respondents apply the pre-wet liquids just prior to the spinner, even though I had it in red, kind of implying that it's not necessarily the best practice, but that's the most common practice. And then followed by pre-wetting in the chute or at the auger, especially when you want to achieve a slurry mix, might be best to do it at the auger. And agencies have, as you can see, there are variations of where you should apply the liquid. And pre-wetting on top of the chain right before the salt enters the chute or in the auger works better for the salt to achieve saturation condition than at the spinner, because at that point it's a little bit late. But again, this may cause some corrosion concerns. Now, in terms of common delivery systems, well, I should clarify that the reason the conclusions are organized in this way is because in the proposal, those are the fundamental questions we wanted to pursue. So common delivery systems, as you can see, again, spinner is the most common, not necessarily the best practice. But the assumption that at the spinner you can achieve optimal efficiency of the pre-wetting process, I would put a question mark there because again, there's no scientific evidence, right? Another type is really simultaneous spreading of the solid and liquid before they hit the road. And again, this one you have a little bit more control with the liquid emitter tubes having a directional valve to control the spray pattern. Again, the liquid emitter tubes revolve in sync with the spinner disc, therefore creating a more uniform mixing of liquid and solid materials as they're applied. Again, all these are based on server responses. They're not necessarily based on a well-controlled study or quantitative investigation. It is desirable to include an agitator in the feed system to break down some of the solids. Again, this is based on user experience. And later I mentioned one recent development is there's a technology to crush the salt even further to finer salt that seems to help the salt stay on the road longer. In terms of type of pumps, this is a very interesting one because we had back and forth on this one because the majority of the 34 civil respondents reported they prefer the hydraulic pump because they think it's easier to calibrate, less prone to corrosion issues, and therefore less maintenance and less downtime of the spreader. Typically, the old systems or old trucks had electrical pumps with a flow rate capacity of 5 to 7 gallons per minute. That's typically sufficient for, if we're talking about 8 to 10 gallon per ton pre-wetting rate and so on. But for the higher application rates like slurry, we probably need higher flow rate capacity. So that's where the new hydraulic pumps typically would bring 10 to 18 gallons per minute. However, WashDOT had a different experience. They had electrical pumps with 10 years of good user experience, and they seem to provide more volume, less expensive, and easier to maintain. So again, we may have to look at the specific brand instead of categorizing electrical versus hydraulic, and both technologies are advancing over time. And some DOTs use a gravity feed system, so you no longer need the pumping. But again, that might not work well for abrasives, just like the zero velocity spreaders. Again, something worthwhile to look into. Again, no quantitative data available. We also look at the type of spreader configurations. as you can see, there are 8 different types identified throughout the server responses, and zero velocity is at the top because I want to highlight that there was a study that zero velocity spreaders and pre-wetting techniques yield better pavement in half of the time of standard methods by reducing salt usage by 70% and salt cost per mile by about 50%. The caveat is the user experience also showed that zero velocity spreaders don't really work well for abrasives. It works well for salt. And then, as you can see, there are many different types of spreader configurations out there on the market. And if you look at the details in the report, the 6 vendors also provide a lot of information on what kind of spreaders they can offer. Now, in terms of nozzle type, hose size, and screen size, those are some of the questions. And we basically found that there are 2 types of nozzles quite popular. One is the fan nozzle, most common, again, not necessarily the best. That's where I highlight with red. I think the stream nozzles would provide an interesting alternative, but again, there's no scientific data to contrast either one of them. This is all based on user experience. The most common hose size is 1 inch in diameter. You would imagine if it's too small, then you may have some maintenance issues. The nozzles or the hoses could be clogged easily. So in terms of screen size, from the user experience, from the vendor information, we're mostly looking at 16 to 80 mesh, 16 mesh to 80 mesh. Actually, the 80 mesh is smaller than 16, right? So preferably, we can crush the sand as fine as possible. Again, there was an error I need to fix in the final report. So basically, ideally, we can go up to, go as small as 80 mesh if you can find a way to crush your sand that fine. There are other concerns in terms of reliability, maintainability, and safety. Of course, most responses say, they are as reliable as any other winter maintenance equipment, but the focus is really on the liquid delivery pumps, where agencies have reported all sorts of issues over the past decade or so. Maintenance is crucial, especially at the end of the season, and calibration at the beginning of the season is also important. The nozzle tends to plug and should be cleaned regularly. System flushing and screen cleaning are required at least twice per season. So those would help address the reliability concerns or maintainability concerns. There's a recent technology from Europe dealing with hot water sanding. Certainly there are benefits, helping the abrasive stay on the road longer, providing really good level of service. However, there's a safety concern. As you can see in these photos on the left is the pattern of the pre-wetted abrasives on the pavement, and they seem to stick well to the road. But if you are in the following traffic, your visibility is hindered by this, evaporation of the hot water. Now, we certainly learned a few things from the agencies in terms of the implementation of pre-wetting practices. Many of them faced initial resistance to pre-wetting from operational staff or other stakeholders like management or even sometimes political stakeholders. But training and information dissemination coupled with effective field trials basically gradually mitigated the concerns and built rapport for this new innovation. And there are some obstacles if your agency is considering transitioning to a pre-wetting practice. Some items mentioned by the civil responses or case studies include cost, equipment, capacity, logistical challenges, and worker availability. Again, this is a photo showing the technology where they crush the sand to very fine and seems to stay on the road, on the pavement much longer, and especially when the pavement is relatively dry. Also, we try to summarize what we identified throughout the literature, the survey, and case studies in terms of recent developments. One of them is new on-vehicle tools such as zero velocity spreaders and modified spinners facilitate precise and effective application of both solid and liquid materials. The second is the use of pre-wetted fine graded salt. Like I mentioned, they seem to stay on the pavement longer, especially when pavement is not too wet, it's a little bit dry or moist. And agencies have reported increased use of liquids. So for that reason, they're shifting to, I guess, migrating to larger tanks, increased pump size, and increased flow rate. Some agencies reported, again, moving that pre-wetting location from the spinner to the chain or the auger. Most of them also use road weather information system, automatic vehicle location, or maintenance decision support system to aid in determining when and how to use pre-wetting. I think this kind of data-driven approach will be, the best practice in the future. And most manufacturers reported having advanced systems for data recording capabilities through the use of plow cameras, GPS, and so on, so that you have more accountability and some more room for improvement. And for the case study agencies, again, 9 of them, all of them have changed their pre-wetting practice since first implementation because of the increased understanding, support, and better equipment and technologies. That's a really good sign. And most of them have also upgraded the equipment to include, again, larger capacity, bigger volume, hydraulic pumps, spray nozzles, ground speed sensors, and live bottom V boxes. Now, some of them are considering changing to other practices, such as purchasing pre-treated salt, just to have less investment needed on the own equipment, I assume. And also slurry application, as we mentioned earlier, in the field, it seems like the higher pre-wetting rate leads to better operational results, and also a more reliable management system in vehicles. This certainly includes some of the data recording or accountability we were talking about in early slide. Now, what about knowledge gaps? We identified a few of them. One of them is the lack of scientific and quantitative knowledge on how various factors influence the costs and benefits of pre-wetting practices, especially for typical road weather scenarios. We only have anecdotal evidence, they work well, like I said, many success stories, but not much on the quantitative scientific information. Again, most survey respondents report pre-wetting can lower the total cost of winter road maintenance operations in terms of materials, equipment, and labor. However, vast majority of them have not yet conducted the cost effectiveness or cost benefit analysis. The second knowledge gap is really we still need scientific or quantifiable evidence of effectiveness under various pre-wetting operation, especially when dealing with application rate. Even though I mentioned earlier, we recently conducted a lab study, concluded with 8 to 16 gallons per ton of salt was doing really well in the lab. But again, the traffic simulation was really difficult because in the lab, you don't have as much traffic. The traffic is much slower than the real environment. And in the field, there's so many diverse road weather scenarios. So there's an urgent need to study and optimize both the appropriate pre-wetting rate of liquid to solid and the appropriate application rate of the pre-wetted salt for the typical road weather scenarios. That's our second knowledge gap. Just be cautioned that the optimum rate really depends on a lot of things. The climatic conditions, the pavement surface condition, traffic volume and speed, particle size, distribution of the solids, type of pre-wetting liquid, especially if you're thinking about unconventional pre-wetting liquids such as beet juice blend with salt brine. Methodology for pre-wetting, equipment type configuration, ground speed, and so on. So there's a lot of factors to consider. So that's why it's so difficult to have a very specific guideline for each type of scenario. And last knowledge gap is really there is a need for experimental design that is statistically valid and practically feasible in terms of field evaluation of impacts of different pre-wetting practices. Arguably, a multi-state testing program is needed to provide a reasonable representation of diverse scenarios, equipment, liquid, and solid products. especially those seen in northern states. And in terms of field testing, again, traffic would be a really big deal. So I put in here under variable speed traffic. And then, how pre-wetting actually works. I mean, how do we achieve the benefits? On bounce and scatter, we have a little bit quantitative information. On reducing salt application rate, again, we have some case studies. On improving friction, we have, again, limited number of case studies. Reducing time to regain bare pavement, as you would imagine, that would change depending on the field scenario. And then reducing corrosion, like I mentioned, there's no scientific study out there yet. Increased longevity of winter traction materials, yeah, especially hours after application. I haven't seen any data on that. So that concludes the key findings, and now I hope to hear your questions. Thank you.
All right, thank you, Xiaoming. So really, we only had one question, and that was from Clay Adams in Kansas, and it just came up. It says, do we have a study underway to come up with optimal application rate? I thought that was what this was supposed to be. I'd prefer to hand that over to one of the project champions if they were on here. I don't think so. The Patty,
yeah, I'm on.
Maybe James is. Okay, go ahead, James.
Yeah, Clay, if you remember, initially, that was part of what we were trying to accomplish, but we pared it back to basically do this in two steps. And the first step was what Xiaoming and his team have done so far, and then the next step would be to accomplish a number of, would be to look at quantitatively, what is the best rate. And then actually, I also want to say I hadn't thought of also looking at what is the best rate in terms of accomplishing corrosion inhibition, for instance. And so I appreciate that you mentioned that. But anyway, Clay, hopefully that answers your question. It would be phase 2 would get to that answer.
Right. And I think that was the only question.
Yeah, thanks, James, for the refresher. This just seemed like a lot of old news to me, and so that's why I was kind of surprised there wasn't anything done with the application rate information, or at least what all the different states are doing and their experience with it. So, but look forward to phase 2. If is that underway, or has that been proposed yet?
No, that
I guess
would
I'll
be,
let Greg.
Yeah, that's right. We were still waiting for this project to wrap up. Obviously, this came beyond the idea generation phase for 2021. So I would expect us to start considering that for 2022.
But one thing, Clay, is that this did look at it did include a survey with what states are doing and what their experiences are. But as Xiaoming pointed out, that that's just their experience. Hasn't been any tests to prove the validity of those experiences.
Yeah, thank you for clarifying that. And also, Clay, I think, yes, when we look at the survey responses, the thing is everybody's listening, maybe hearing it from other states, so they're basically doing similar things, like 8 to 12 or 8 to 16 gallons. And when the equipment allow them to do the slurry, they try slurry. But again, that's all anecdotal, at this point.
And then I think the other there was like 2 parts really to Clay's question, and the other is something to the effect of, wasn't there another project underway? And I think, Clay, and what you might be thinking about is 1901, which was looking at expanding the application rates that we'd put out in a previous project that were for brine application rates going sort of beyond the normal temperature range. So that project is underway with the University of Wisconsin, well underway. And about halfway through right now. So that could also, and it's not really pre-wet, obviously, it's about brines, but obviously that's going to add to the knowledge as well. All right. Well, hearing no other or seeing no other questions in the chat box, again, I just want to reiterate that this project was recorded. We'll be posting on the website on the project page, and that this is the final report was submitted just over a week ago for review this month, and so the project committee will be looking at that and providing comments back to the investigator, and then we will wrap this project up at the end of this month. And I guess that's it. So I just want to thank everybody again for your time today, and hope you have a good rest of your week.